Good day, ladies and gentlemen. For this video, we will be discussing what is RSA algorithm. Before we start, let us first define what is RSA algorithm. So, RSA, also known as Reverse-Shamir algorithm. An algorithm uses the encrypt and decrypt message. It is an asymmetric cryptographic algorithm. We all know that in asymmetric algorithm, we use private key and public key for encryption and decryption. While in symmetric, we only have one key for both encryption and decryption. As we go deeper, let me show you the formula of encryption and decryption using the RSA algorithm. For encryption, C is equal to P raised to E mod N, where C is ciphertext and P is the plaintext message. For encryption, we need to the public key, which is E. And for decryption, P is equal to C raised to D mod N, where P is the plaintext, C is the ciphertext, and D is the private key. Now, let us see the key generation steps. The first step is consider two large prime number of P and Q. Calculate N equals P times Q, where P and Q is based from the first step. Phi of N is equal to P minus 1 into Q minus 1, where phi of N is what we call Euler's tangent function. Select public key P such as that to satisfy the two conditions, which is GCD of phi of N and E is equal to 1, and E should be greater than 1 and it would be less than phi of N. That is, we need to select one number E that is co-prime to phi of N. Co-prime are positive integers that if we divide, the answers is 1. Find the value of D, or the private key, such that D times E mod phi of N is equal to 1. Now, let us see the example of key generation steps. For first is to consider two prime numbers. We will use P is equal to 3 and Q is equal to 5. You can use any two prime numbers 1. The next step is to calculate the number of N. The formula is N is equal to P times Q, where 3 times 5 is equal to 15. So the value of N is 15. And next is to calculate the value of phi of N. So phi of N is equal to P minus 1 times Q minus 1. Let's substitute the value of N and P, which is 3 and Q is 5. So this will be the equation phi of N is equal to 3 minus 1 times 5 minus 1. Phi of N is equal to 2 times 4 is equal to 8. The value of phi of N is 8. And next is to select the public key. The condition is to satisfy the two equations, which is GCD, E, and phi of N is equal 1. And the value of E is greater than 1 and less than phi of N. To satisfy the condition, we can use GCD 3 times 8 is equal to 1, GCD 3 times 8 is equal to 1, and GCD is equal to 1. So E is equal to 3 to satisfy the equation. Next is to find the value of D. So we have the formula. D times E mod phi of N is equal to 1. D times 3 mod 8 is equal to 1. Consider is equal to 3. 3 times 3 mod 8 is equal to 1. 9 mod 8 is equal to 1 and 1 is equal to 1. So next, here we now have public key, which is E and N, which is 3 and 15. And private key D and N, which is 3 and 15. Now we can move forward to encryption and decryption. For encryption, consider plaintext is equal to 8. C is equal to P 8 raised to E mod N, where is C is equal to 8, which is the plaintext raised to 3, which is the public key mod 15, which is the value of N. C is equal to 512 mod 15, So ciphertext is equal to 2. For the decryption, we can use the formula P is equal to C raised to D mod N. So P is equal to 2, which is the ciphertext, raised to 3, which is the value of private key, mod 15, which is the value of 10. Now, P is equal to 8 mod 15, the plain text will be 8. So that is the process of the RSA algorithm. So next, elliptic curve cryptography. So first is an asymmetric public key crypto system. And next, it provides equal security with smaller key size of compared to non-ECC algorithms. And next, it makes use of elliptic curves. And next, elliptic curves are defined by some mathematical functions. And next, which are cubic function, for example, y squared is equal to x cubed plus ax plus b, which is an equation of degree 3. And we can see here in the diagram, this is an elliptic diagram. We can see in this diagram an elliptic curve. This is x-axis and this is y-axis. We see here the elliptic curve, it goes to infinity, but we are limiting this curve up to the value which we are considering over here is n. The diagram shows the elliptic curve is symmetric to x-axis, that is space above x-axis, and the space below x-axis is equal. That is one of the property of elliptic curve. Next, the next property of elliptic curve, if we draw a line and the curve it creates maximum of 3 points, that is, it will touch maximum of 3 points. We can see here one line is drawn, it creates the curves and 3 points. We are naming these 3 points P, Q, and R. And next, PCC, key exchange. And next, global public elements. Next, we need 2 public elements. First element is EQ times AB. E here is the elliptic curve with the 2 parameters, which is A and B, and Q. Q is any prime numbers or an integer of the form of 2 raised to m. Second element is G, which is the point on the elliptic curve. In the example, we will going to use user A and user B. We are going to generate private key and public key to the both user, and then we will going to calculate the secret key for both user. And next, the first step is to generate user A. We need to select one private key of the value of NA should be less than n, where n is point where we are limiting our elliptic curve. Then based on the selected private key, we have to calculate the public key of user A. So PA is equal to NA times G, where NA is the private key of user A and G is the point of the elliptic curve. Repeat the process on user B, that is the process on how to calculate the public and private key. Next is to calculate the secret key, which is shared by user and B by using the formula. And next, K is equal to NA times PB. NA is the private key of user A. PB is the public key of user B. We all know that public key is shared by both users. In the same way, we are going to use the private key of user B and the public key of user A. Next, for ECC encryption, let the message be M. And next, first encode this message M into point on elliptic curve. Let this point be PM, where P is the plaintext point and M is the message. Next, for encryption, we need to select a random positive integer K. And next, we will calculate the cipher point that we will be going to send to the receiver. And next, CM is equal to KG PM plus KPB is equal to CM is the ciphertext, and K is random positive integer, G is the point on the curve, and PM is the plain text points plus public key of user B, which is the receiver. After calculating the point, it will be sent to the receiver. And next is the decryption. For decryption, multiply X coordinate with receiver's secret key. This will be the formula. Kg times ND. So next is to subtract Kg times NB from Y coordinate of cipher point. This will be the formula. PM plus KPB minus Kg times NB. PM plus KPB minus KPB. Channel both the KPB. The answer is PM. So the receivers gets the same point. That is how elliptic curves work. So thank you everyone and God bless.